The two halves of the motion bracket were orphaned from the main etched fret some time ago when other parts were removed from around them, so it remains now to just remove the remnants of these tabs and clean them up. These edges are going to have to be bent up with great care because they're so thin. The real things had a flange along the edge, which I may try and recreate. I'm also going to have to modify this gap. The slide bars are going to attach in there, and the ones I've used from the Black 5 kit are wider than was envisaged here, so the gap will need opening. But before we can get to any such refinements, we need to join these two pieces together, and for that we're going to use this 7mm frame spacer strip. So these brackets will line up in the notch that's in the top of the main frames so that the front driving wheels pass through the middle of the big hole, and the rear edge of that big hole is going to line up with the inside edge of the frames. So we need to prepare a length of this frame spacer strip that'll sit in between the frames like this, and then the two halves of the motion bracket can solder onto the top of it. So once I've established that the end of the strip is square, I can give it a quick rub over with Gariflex to get it nice and clean. So the important thing to note when we're getting ready to solder these pieces onto the PCB strip is that these half-etched lines need to go on the bottom. So this is going to be its approximate position with just a thin strip of the edge of the PCB showing in that window, and that should set these to the right width overall. The technique that I'm going to use to fix these in place is to sweat them onto the PCB. So I need to flux the end of this PCB for about the same length as the motion bracket itself, and then tin it quite generously with solder. And the bit of the underneath of the motion bracket, where those half-etched lines are, I'm going to tin as well. I'll need some more flux in between where the two layers are going to be joined together, and also I'm putting some flux on the top of this motion bracket part so that I can get good heat transfer from the soldering iron. I need to line this up very carefully now so I can see the thinnest of lines of solder glinting through on the inside of that aperture in the motion bracket, and then heat it from on top, and the residual solder on the tip of the iron is going to help with the flux as well, that heat to transfer down. And as the brass gets hot, the solder on its underside melts and fuses to the solder that's tinning the PCB. And then we repeat the exercise with the other half of the motion bracket. And before I finally solder this second one on, I want to make absolutely sure that these are perfectly in line with each other. Otherwise, it's not going to fit into the little recess properly on both sides of the main frames. When the soldering's done, it's into the vise, gripping it by the remaining part of the frame spacer strip, and using a razor saw, slowly and carefully separate the part. And when that's done, while the razor saw is still in my hand, I'm going to use it to gap the PCB top and bottom so that we maintain our split frame arrangement. And actually on the top side, I'm going to put two gaps in here, so I've got a central section which is isolated from both frames, and I'm going to use that later on to solder in a piece of brass that will connect this motion bracket to the cylinder block at the front to give the whole thing a bit more rigidity. They'll be joined together by the slide bars anyway, but there's not a very large contact area with those, so this is belt and braces. And then the obligatory quick check with the multimeter to make sure no current flows between these sections of metal, and then turn it over, and only one cut is necessary on the underside. Now, when I tested this PCB in between the frames earlier, it was a very tight fit, and I don't want to risk pushing those frames outwards. So I'm just going to take a little bit off each side of this PCB with a fairly coarse file. This file's got a blind edge, which is the one that's rubbing against the brass, so I know I'm not going to damage that. But I'm being careful here to take the same amount off each side, so this is going to be a smooth sliding fit in between the frames. And there it goes. I've got that little recess that it should just line up nicely in. Nothing should protrude above the top edge of the main frames, so the body, when it's fitted, can sit down nice and flat. And I'm noticing now as I watch this film back that I've not got this in quite the right place. It's out of the notch at the front, it's too far forwards. But we can see that we've got plenty of clearance around here for the wheels and the valve gear on the inside of this motion plate. Here's the cylinder and slide bar assembly that I made in the last part. I'm just measuring the gap between the front and rear cylinder end plates because I want to put a piece of PCB soldered in between here, and then we can gap the metal. So transferring that measurement with my digital calipers onto another piece of frame spacer strip. I'm going to use the razor saw to cut this off as before, and then we can file it so that it's a good push fit in between those cylinder end plates. Now I've got lucky with this because it's a perfect fit in between these end plates, and they will grip it and hold it in place while I solder it. What I want is to set this down 12 thou below the top edge of these front and rear plates so that I can solder a strip of brass onto the top of it and it be at the right level. So, as if it was designed for this purpose, there's a little square of brass that's part of the fret. It's not a component of the kit, but what I can do is if I put it on top of my PCB spacer in the middle, it just fits perfectly, and then I can use something to push this down and get it level with the top of those front and rear cylinder frames, and that will set it to just the height I want it to be, and all will become clear as to why I want it set down there in a few minutes. But I can make sure it's aligned in the centre and then solder this at the top and at the bottom. So here the parallel jaw Morn pliers come into play again as a little hand vise, and I want a fairly generous lump of solder in there because I want a good decent fillet. This is going to be an important mechanical joint, and I'm struggling a little bit to get enough heat in here onto the brass because the jaw of the pliers is acting as a heat sink. So when I turn it round, I'm going to try putting a coffee stirrer in between the plier jaws and the brass just to act as a bit of a thermal barrier there, and that should make the soldering much easier. Unfortunately, once I've soldered this PCB in place, I can't put the cylinder block back in the frames because the top of the bogey pivot interferes with it, so I need to file that bogey pivot housing down. It's taller than it needs to be, so I can file it down flush with the top of the nut that's inside it, and hopefully that will give me enough clearance. So the moment of truth. Perfect. But I need to think now about what happens when I insert the bogey pivot bolt from underneath. It might poke out from above this nut, and so I want to have a hole in the PCB that it can protrude through if it needs to. So inspired by what happens when I have a filling, when the dentist uses an ink pad to locate high spots that need grinding away when the filling's being finished, I put some ink on the end of the bolt and transferred a little spot of it to the point in the PCB where I need to drill the hole. So I can make a dimple on the exact spot with the point of my scriber and use that to start off the drill and drill a nice hole. I'm using a 1.5mm drill to do this, so that I get a very generous clearance around the 14BA bolt as it passes through the hole. The bolt should be isolated from both frames anyway, but I'm taking a belt and braces approach to avoid any chance of short circuits. And I can just show you now where I want a strip of brass to join these two parts together. Back to the motion bracket now, and I want to bend up these sides, and to do this I'm going to use this tool, which is a small hold and fold. This one's actually called the Bug, and it's perfect for gripping thin narrow little bits like this that need bending. I could have done this in my vice jaws if I wanted to, but this is just another tool that I've got that I can show you how to use. And you've got this long razor blade like piece that you push under and get good leverage all the way along the fold to get a nice accurate bend. I'm going to check this with a square now, and the camera's at a funny angle so you can't see whether it's not quite square, but it's springing back a bit. So what I want to do is just ease this out of the jaws of the hold and fold a little bit so I can see more of the bend, and then I can push this with my square a bit past 90 degrees and then bend it back, and it should hold that bend then. And that's just right now. So we can then remove this from the tool, give it a quick inspection, looks good, and we can repeat for the bend on the other side. So I'll just show in close up what this looks like now. And if we just check this against the underneath of the Pico plastic body, these brackets should be just about exactly the same width as the footplate width. They'll fit a bit further forward than this when we've carved bits off the underside of this body. So when it comes to the brackets at the front, we can use smooth jawed pliers and just bend these by eye to approximately the right position, which is not quite 90 degrees. They've got to be perpendicular to the slide bars, which themselves are in line with the cylinders, and they slope down ever so slightly. So I bend both of these up and look at them from the side to see that they're approximately the same, and then we can put them in place on the frames and set the correct angle for them. So there you can see this is not quite 90 degrees, there's a gap there. So if we look at the bottom of the slot where the cylinder block's going to go, you can see that that has a slight slope in it. And if I use my square, line up the edge of the square with the bottom of that gap, the end of the square should give me the angle to set the motion bracket. I need to check both sides, make sure they're just about right, which they are, and then double check again if I fiddle about with them that they are both actually set to the same angle, which as before I can do from looking at the side, and they line up. Once I'm happy that the angle is correct, I don't want it to move, so I'm going to set it in place by putting a fillet of solder in the fold line. We can move on to the next little problem now, and that is that the gap in the slide bar support bracket is not wide enough to support the slide bars, so we need to open it out a little bit. Actually, it turns out we need to open it quite a lot because the gap is just about the same as the gap on the inside of the slide bars, not the outside. So I'll try and very carefully measure the distance between the outside of the slide bars without squashing them, and that's about 3.5 millimeters. When I measure the gap of the inside of this bracket, it's about 2.7 millimeters. So I want to try and very carefully file equal amounts of the top and the bottom. So I'm using the same file I used before with the blind edge, and I'm counting the number of strokes and trying to put equal pressure on top and bottom. 4 strokes to the top, 4 strokes to the bottom, and the gap has increased, but not by nearly enough. So I'll try again with another 4 strokes each way. Check again, and I'm up to 3.35 millimeters now, which is nearly there, but I'm concerned that the amount of metal on the bottom leg of the bracket is very, very thin, so I'm going to try and take some off just the top side now. If I turn this round, you can see how thin that's got, and this isn't going to be quite so even, but I'll just have to hope for the best. Just 2 or 3 strokes should do the job, and then we can bring in the actual slide bars, off them up, and see if they fit. And that's just about perfect. So having done one side, if I hold this bracket up end on, you will hopefully be able to see the difference. So I'll do the same again on the other side, this time having to hold it in the opposite corner of the vise to get access. And then these corners, which were rounded before, have now become square because the curve has all been filed away. So I'll just reintroduce a radius on there to make it look nice. So we can test the fit of these 2 parts together now, and both sides are able to slide into the brackets at once, which is good. And now we can test them while they're loose, both together in the frames of the loco. It's a little bit of a fiddle to get both of these components in place without them falling apart, but with a bit of perseverance we'll see that they do fit. Before we go any further with the assembly, it's worth just getting the crossheads and checking that they do still slide up and down, and that nothing with these motion brackets is getting in the way of that. Much easier to adjust them and file extra bits off now than after everything's soldered up solid. That is catching a little bit on there as it goes in, but I think it's the extension at the bottom that's catching. So once they're soldered together, that can be filed flush. However, before everything gets soldered together, we need room to get in between these slide bars in order to cut the isolation gaps in this brass. Because I want this electrically dead section in the middle to put my connecting strip between the motion bracket and the cylinder block, I'm going to have to make 2 cuts in each side of this, which doubles my chance of something going wrong. As well as cutting through the brass, of course, I've got to cut down into some slots and make some gaps in the PCB. Just holding this while I saw it is actually quite awkward because it's got bits sticking out on every side. This side's not too bad, but when I come to saw on the other side, it's easier if I rest it on a block. I'm just using my steel square here, but it's not clamped very securely, it's moving around all over the place. And this is the point where I should advise those of a nervous disposition to look away now for a few seconds, because just as I'm about to break through this metal, disaster strikes. My solder joints have failed and the 2 cylinders have separated. Let's see that in slow motion. I suppose the good thing to come out of this is that it lets us have a look at the inside of the cylinders and see how nicely everything's soldered together. However, after a moment of despondency, we can rally ourselves, and it turns out that this isn't actually too hard to fix. With these parallel jaw pliers, and really, if you haven't got any, you must get some, they're the best things in the world. I can clamp this together, resolder these joints, and this time make sure I get good heat conductivity with the brass, because I think that is what was the problem. Those solder joints just hadn't connected with the brass properly. Maybe it had gone a bit tarnished, but I said the plier jaws were acting as a heat sink, didn't I? So that could explain a lot. So get a good fillet in there, and these should hold forever now. Famous last words, I know. So there we go, all back together and none the worse for its adventure. Give it a thorough eyeballing from all directions to make sure I haven't put it back together twisted in any way. The giveaway will be if the slide bars aren't parallel when you look at them from the sides. But I'm quite happy with that repair. Then it's a case of melting the solder in the middle section to flick away those bits of brass. Sorry, this is a bit out of focus. And then just with the razor saw, go through those grooves again, because I've put more solder on there and I just want to make sure it's not bridged the gap. And that looks okay, but it's important that we check with a multimeter to make sure it really is okay. And I need to remember to check both sides. Now I can start thinking about joining the motion bracket to the cylinder block, so I look to the etch frame to provide me with a suitable strip of brass. And I can measure off an approximate length against the loco chassis. There are the remnants of 1 or 2 tabs that need to be cleaned off, but that's the work of a few moments with a flat file. And then the end section needs to be narrowed so that it will fit between the gap where the motion brackets are attached. So that needs to be quite a thin section there, but the rest of it I'm going to leave as thick as I can. So you see, that's how that's going to fit together need to assemble that fairly accurately so I don't bridge those gaps. To help keep everything in line while I do this, I'm going to clamp the cylinder block in place by inserting the bogie pivot screw from the top rather than from the bottom. So I'm going to start by soldering the slide bars to their support bracket, and looking from underneath, the slide bars need to be parallel to the main frames, and the edge of the slide bar should be just in line with the edge of that support bracket, and I can tweak things in and out with tweezers if I need to, just a little bit. If that bottom support bracket is sticking out at all further than the slide bars, it's going to catch on the drop link of the crosshead. I need to hold these slide bars tight up against the top and bottom of the bracket while I solder them in place, and to do that I've splintered a coffee stirrer and wedged the splintered end in between them, and that's just holding them with the right amount of force. So I can add some flux. Bottom one's easiest, always do the easiest one first, and then not too much solder here, but you do need enough to make a good joint. Then the top one, we can go in from either side, a bit more metal to attach to at this point. I need to dwell long enough with the iron to make sure that solder's flowed properly and it's wicked right into the joint. Once I've soldered all 4 slide bars to their brackets, it will be safe for me to remove the screw that's been holding the cylinder block in place, and that will give me access to solder this brass bar to join the motion bracket and the cylinder block. You will see there that I've had to put a slight joggle in the end of this brass bar just to lower it down so it's at the right level for the PCB, and the rear section of it is level with the top of the frames. So that's how it's going to fit. So I need to put some flux on this already tinned bit of PCB at the motion bracket end, and same at the cylinder end. And then just line it up carefully and hold it in place with the tweezers, and as before I'm going to sweat this in place, so I want some flux on the top of the brass, so when I introduce the iron with a tiny bit of solder on it, that's going to get heat transfer, heat up the brass and sweat it onto the PCB. Then I need to do the same thing at the cylinder block end, and I apologise, it seems to have found its way half out of camera at this point, but when it's all finished, this is what it looks like, and this will hopefully give me a much more robust cylinder slide bar motion bracket unit. Now, the process of soldering the slide bars to their brackets will inevitably have got some solder on the faces of these slide bars, and it's important I clean that up. Now, I'm going in with my horrible file that's going to remove the solder, and once I've got that back down to the bare metal, I can go in with my nice expensive number 6 cut file and smooth those faces off. I'm doing this so that there's no chance of the crossheads sticking or binding as they're trying to slide up and down here. And once that cleaning up is completed, of course, we need to get the crosshead and test it. And the acid test is if I put it in place and tip this up, it should just drop past the bracket, which it does, first time. And I'm just going to subject this to some more comprehensive testing with my tweezers, putting pressure at different angles to make sure there's no way this is going to catch on anything. I'm curious to know at this point whether the combination lever is going to have room to swing in front of the slide bars. So I'm using this etch frame that happens to be the right sort of width to test the gap, and it looks like there is just about enough of a gap there. Of course, I don't know how far forward the combination lever is going to come, so it may be that the slot's not deep enough and these things aren't going to work at all. On the right hand side, however, it's a different story, and there's absolutely no room to squeeze a combination lever in this gap at all. And that makes me think maybe these castings weren't quite symmetrical, or maybe I've not assembled these very accurately. Whatever, I could, if I wanted to, go in with a tiny file and spend hours and weeks just filing this bit of metal thinner to try and create a gap, but I don't really want to waste a lot of time doing that if these combination levers are going to come too far forward. It may be that the best course of action is to cut off these valve spindle crosshead slide bars altogether, but we're not going to find that out until we're much further on with the construction of the valve gear. So I'm going to leave it like this for now.